And he has a lot of stuff he's been working on, so I kind of want to hear it.
Well, we should be recording now.
Okay, well, go ahead and give an update. Dan.
Yeah, I know via some chats with Vlad that he's been pushing on polishing up and kind of extending his safety proof and consensus proofs, but in the propositional logic forms. I'm not going to get into them because he's kind of sending them stream of conscious every once in a while, and I have not fully digested them. But I know he's trying to tighten all that up for his paper, which I'm going to be pressuring him to start getting a draft out soon because he's trying to get that out by DEF CON. But I imagine next week, I suppose, he'll give us the big update. As for the code base for Vlad's CBC and Python, we've added support for Python 3. We've integrated that testing language that Nate was showing us last week. We've added unit tests and testing to most of the framework. We've added a continuous integration via Circle CI. A big thing that I just finished was there was no real notion of a validator set beyond some config file that was referenced throughout. Like the number of validators and then the weights were just kind of referenced throughout the code base. So I've made validator set its own class, and which was kind of ended up being a major refactor, but sets us up to start experimenting with validator rotation, which is exciting and something that Nate and I are going to be talking about this week to see if something we can get out hopefully before DEF CON. Nate has worked on a new oracle. It's kind of it's called the Turin oracle, which is based on Turin's theorem. Are y'all familiar with that? Turin's theorem states, let G be any graph with n vertices such that G is K R plus 1 free. So G is a graph with n vertices, and there's no clique of size R plus 1. Then the number of edges, it gives a formula for the maximum of edges. So using that, we can kind of, using the number of edges, like using the similar clique oracle, we can get the minimum size of the maximum clique via just counting the edges and knowing the number of validators. And with that, then you can assume the worst case, get the lowest set of validator weights of that length, and see if you can get safety from that. So he's experimenting with that, and that's under code review. It seems like definitely an interesting approach, and it's way, way more efficient. I wonder if you only use that as the safety oracle, if it maybe opens you up to some sets of attacks where people might try to game, might try to prevent safety by gaming and adding fake validators, or not fake validators, but small weight validators to try to flood the validator set, and just kind of making that algorithm not work anymore if you have a really long tail of small validators. Anyway, that's what's been going on from what I've seen in the past week. There we go. How about you, Greg?
Yeah, thanks. So I've been working with Brad a little bit on the over the weekend. I came up with the alternative logic than the one Vlad was looking at, using the ladle algorithm. So I'm waiting to talk to Vlad about that logic. to describe the consensus states, because that's what he's iterating over. He's iterating over the consensus states, and it's pretty easy to describe the consensus states once you have the bet data structure. You just have to add a par operator to represent the different validator states. So then you have a term language, and then from that term language you can use ladle to generate a logic. So I've got that ready to go when Vlad and I can coordinate. And then I've been looking at a different approach to. I've been thinking a little bit about turning synchrony constraints into economic constraints, so that you can get around FLP the other way, by flipping the protocol upside down. So FLP is going to happen if you have no synchrony constraints. But the thought is, sort of, you have to pay for ultimate freedom. But since you have to pay, you end up, there's a ceiling. There's a ceiling on the no synchrony constraints. So I've been working out a version of that to see if that helps us get convergence in a different way. So that, but I need a little bit more time to write all that down before I can talk about it coherently. But those are my main two updates. I'm looking forward to this cleaned up Casper code base, so we can start coding them up in Rolang.
Absolutely.
Along quite well. I'm excited to be talking about it at DevCon.
Oh, excellent. How's the VM rewrite?
We will demonstrate the, what we call the rosette.void, which is just 4 opcodes running in Scala. This Wednesday. It's been ready since last Wednesday, but they didn't want to do a demo.
Excellent.
Yeah, so I'm very excited about that. And that's pretty much it on my end. Do we have any more parties? I can't really see my phone because I'm charging.
Hey, Nate. Yeah, I gave a quick update, just saying all the things that are happening in the code base. I don't think I gave the turns Oracle due justice. If you want to give us just a quick recap of what you've been doing with that Oracle.
Yeah, sure. Cool stuff. Yeah. I'm sure you said this about the code base, but it's reaching new heights every day. So it's looking really good. But yes. So the idea of the turns Oracle is that it's kind of a modified version of the clique Oracle, in the sense that the clique Oracle, we construct edges, and then from edges we build a graph, and then in that graph we look for cliques, right? And turns Oracle kind of takes a similar but a little bit different approach, in that it builds edges in the same way, but instead of then building a graph from those edges, it just uses the number of edges to decide on what the minimum size of a clique must be. With a minimum size, there exists a clique of at least this size somewhere in the graph, right? And then we kind of assume that the weights of those validators are the smallest weights that they could be as well. So we're sure we're getting a lower bound. And what this helps us do is just avoid that, exponentially complex or whatever, clique search in the graph, which, hypothetically, if there's a very large number of validators, might give us some efficiency gains, but for a trade-off of being a lower bound. But that's pretty much it. Yeah, that's it for me. Otherwise, just cleaning out the repo and stuff, and it's really starting to look great. So
what's the graph? Is it the graph of connectivity amongst the validators?
Yeah. So it's not really connectivity, but it's like there exists. It's, remember those 3 conditions. It's like there's an edge between them, if, you know, their latest messages are in each other's views are on the candidate estimate, and they can't see a later message from each other that isn't on the candidate estimate.
Got
So
it.
it's kind of like they're kind of they're not necessarily locked into each other, but they kind of have this relationship where they unless everyone else kind of works together, they can't really show each other messages that aren't on the candidate estimate. So yeah, that's it for me though.
Cool. You might want to look at my notes on the theory of graphs, because you can probably get a very efficient description of this. Interesting. I'll have to think about.
Yeah, I'd love to. I'm not totally sure I'll be able to understand it all, but I'd love to check it out.
They're really simple. There's nothing to it. The main thing is just that it's a data structure that's recursive, right? Like most people describe graphs as collections of nodes and edges, but that's like not how we think about most things in computer science, right? You don't think about a list as the list of all the elements, the sequence of all the elements. You think about a list as either the empty list or con something onto a list. That's the recursive spec, and that's very, very useful. And the same that my little structure is just exactly that. But the nice thing is that you can describe subtypes as filters, essentially filters on edges. So you can connect it to your oracle in a fairly natural way. So I'm just thinking about how to do that.
Oh, cool. Yeah. That sounds interesting. Sure.
Yeah. Anyway, do we have any other updates?
I think that's all we got in the room today.
Sweet. Lovely. We can yield back the time so we can get back to work.
Cool. Absolutely. Okay. Well, I might talk to you all throughout the week. Otherwise, talk to you all on Monday.
Yeah, sounds good.
Yeah.
Let's see. Monday is the 23rd. Is that right?
Let me check. 23rd, yeah.
Okay, cool. All right. And then I guess a week from then, it'll be like 2 days until DEF CON.
Yes, it will.
All right, so I guess it makes sense to have a Casper then, and then we should definitely have is everybody going to DEF CON?
Yeah.
Absolutely.
Cool. All right, well, let's have a Casper meetup at DEF CON.
That sounds awesome.
Yeah, looking forward to it.
Cool. All right, guys. See you soon.
Yeah, thanks everyone. Hey, Nate, you want to hop on?